Okay, so next up we have question 9. So part of the graph of f, which is the reals positive mapping to reals for the function f of x equals x log e to the x is shown below. First up, we're asked to find the derivative of x squared log e to the x. So the derivative is going to be the product rule. So we've got x squared multiplied by log e to the x. So what we're going to do is we're going to call u equals x squared, and we're going to have v equaling log e of x. So du dx is simply 2x, the derivative, and dv dx equals, so log e to the x, if we look at the formula sheet, we see that it just goes to 1 on x. So now product rule says that dy dx equals u dot dv dx plus v dot du dx, or multiplied. So here we have u as being x squared, and we're going to multiply that by 1 on x, and then we're going to add on to that our v value, which is log e of x, and we're going to multiply that by our du dx, which is 2x. So all in all, our derivative of this is x squared times 1 on x just gives us x, plus 2x log e of x. And the nice thing here is it's looking like this part we'll be able to use here. They look similar. So indeed, part B says that we're going to use our answer from part A. So we'll just remind ourselves what that was. We said d dx of, if I just go back for a second, x log e to the x, x squared log e of x equaled x plus 2x log e of x. So just to double check, our derivative of that x squared log e to the x was in fact x plus 2x log e to the x. So we want to use that result to find the area of the shaded region in this form. So that's important. We need it to look like a log e of b plus c. So we're just looking for those a, b and c real non-zero constants to find this area in here. So what we want to do is we want to find, I'll just put it in red, we want to find the integral of x log e of x dx between 1 and 3. That's what we want to find. And we already know the above in the black text. So all we're going to do is we're going to integrate both sides. So I'm going to integrate this, I'm going to integrate this, both with respect to x, and then we're going to be able to hopefully isolate out the part that we want. So next up, we're taking the integral of d dx x squared log e of x dx, and that's still integral of the integral there, plus 2 by the integral of x log e of x dx. So remembering here, I can just take a constant out the front, and I can also split up over an addition sign to create two integrals. So that's all I've done in that line. So just get rid of that to make it sensible. So what we know about this first term is that my d dx an integral dx will undo itself. So all I'm going to be left with from this term is x squared log e of x. That's all that's left there. And we can say that that still equals, so the integral of x dx is x squared on 2. And the next bit we can just leave as being exactly the same, because that already looks like we want in the red. So I might even put that bit in the red. So that looks like what we want. So now all I'm going to do is I'm going to subtract off the x squared on 2 and then divide everything by 2 to get what we want by itself. So we can say that this integral x log e of x dx is equal to x squared log e of x, subtract away x squared on 2, and then we're going to divide the whole lot by that 2 that was remaining. So our very final answer for the red is going to be x squared on 2 log e of x minus x squared on 4. So now with this result, we can use our fundamental theorem of integral calculus to work out the area. And that's the whole point of doing this question. The result that we had was that the integral of x log e of x was equal to x squared on 2 log e of x plus x squared on 4. I think that looks right. Sorry, that was a minus x squared on 4. So now putting in the area is just equal to the integral between 1 and 3 of x log e of x dx, which is simply f of 3 minus f of 1, where we could call this section up here capital F of x. So I'm just going to substitute in now to say that my area is equal to, so f of 3 is going to give me 3 squared on 2 log e of 3 minus 3 squared on 4. And then away from that, I'm going to subtract off the next f of 1, and f of 1 just gives me 1 squared on 2 log e of 1 minus 1 squared on 4. So hopefully you can read that. So cleaning up, this would be 9 on 2 log e of 3 minus 9 on 4. Subtract away, that's just a half log e of 1 minus a quarter. So this, anything that's log e of, or log a of 1 is just 0. So that leaves us with nothing there and just the quarter there to deal with. So we've got minus quarter, which is plus a quarter. So my final answer should be equal to 9 on 2 log e of 3 minus 9 on 4 plus 1 on 4 gives me minus 8 on 4, which is 2.